Welcome back, everybody. Today we are going to make a little bit of software that would be, for instance, the change making function of a cash register. So as an example, say you needed to get 99 cents back from a cash register. This would tell you how many quarters, dimes, nickels, and pennies that would constitute. So we will start off with the norm by asking the user what we need. So enter change amount, and we'll just be kind of specific here. We'll say number between 1 and 99. Alright, and so to do this, you might be thinking, how are we going to even achieve this sort of thing? We're going to use a new operator. It's called the modulus operator. And basically what it does, just really quickly, let's do a quick demonstration. When you do division with integers, so say we divided 10 divided by 3, what number we're going to get from our program is the number 3. And the reason being is 3 will only go into 10 3 times, right? Because 3 times 3 is 9. So 3 will go in 3 times, and the remainder is going to be 1. So if we were just to go 10 divided by 3, that is going to be equal to 3. But if we do 10 modulus, that's this like percent sign, 3, that is going to give us the remainder of what's left over. So 10 modulus 3, so we have left over 1. Hopefully that makes sense. I'll just give another example really quickly here. So let's just say instead of 3 we had 5. So 10 divided by 5, so a nice clean number. So 10 divided by 5, it's obviously going to come out to 2. Now if we did 10 modulus 5, it's going to come out to 0 because there's going to be nothing left over. It's a nice clean division with integers. So we are going to use this tool right here, the modulus, in order to figure out our problem of how much change we need. So we're going to create some variables. They're going to be integers, nice solid integers, and we're just going to create just a letter for each piece of change. So we'll just go Q for quarters, D for dimes, N's for nickels, and P for pennies. And we'll just write got a note right above that. So what we're going to do, we'll take in from the user how much change they need. So we need to create a variable for change as well. And this will just hold how much change is remaining to divvy up. Alright, so quarters, it's going to be equal to whatever change is divided by 25. So we'll kind of put notes next to this just as an example. So say someone put in 99 cents. So that's probably the best example for this problem. Someone puts in 99 cents. We're going to take change, which is 99, divided by 25, and the most it could go in is 3. So we're going to have something left over after that, but Q is going to be 3. Now change, how much change we have to divvy up, is still 99. We need to adjust that. We've taken 3 quarters, we've subtracted 75 cents from it, right? So we're going to have 24 cents left over. So to get 24 into change, we need to modulus that 25 from it. So we will say that change is equal to change in its current state, which is 99, modulus 25. Does that make sense? So we're saying that 99 modulus 25 is going to have a leftover amount of 24, and that's what's going to be in change afterwards. Now, you see me doing this, it might be a little bit confusing that we're doing this right here, where we're taking itself and equaling it to itself. There's actually a shorthand way that we can do this as well. It'll save you time and maybe look a little less confusing, where we would say modulus equals 25. And this is a nice shorthand way to do any sort of math. say we wanted to take change and add to it, we could do plus equals, do minus equals, divide equals, times equals, anything equals. But right now we just need modulus equals. So at this point, change is going to equal to 24. So now we have our quarters set. We're going to do the same thing with dimes. So we need to get dimes out of 24. So we're going to say D is equal to change divided by 10. And so that's going to come out with 2. Obviously 10 can only go in there twice, and there's going to be leftover of 4. So change now is going to be equal to modulus equals 10. That's going to be left over with 4. And so for nickels, we only have 4 cents. Nickels are going to be equal to change divided by 5. And this should come out with 0 is what we're expecting. And change, we're going to make that equal to percent equal 5. And we should be left over with 4. So we didn't get any nickels out of it. But we need to get 4 pennies. Since it's just division by 1 with pennies, we're just going to say that P is equal to whatever change is. Just because division by 1, it would just be kind of a waste of time. So pennies are equal to what is left over after that. And then we're going to output to the user how much change they need. So we'll say cout, say quarters, Q, dimes, D, nickels, N, pennies, P, and we'll end the line. Alright, so let's put eyes on our code just to make sure that we have everything that we need before saving it and running it. And it looks like we haven't asked yet, or we haven't input the change yet, so let's go cn change. And then we'll save it and we'll run it. Build and run. Alright, pops up here asking us for how much change we want. Let's go ahead and use 99 since that was our test case. And it's saying that we're going to get 3 quarters, 2 dimes, 0 nickels, and 4 pennies. So poor spacing here. We could fix that, but we were exactly correct in how much we needed. Let's go ahead and test it again just with a different amount just to see if that works. So let's do something pretty simple. Let's do like 40 cents. So we're going to need 1 quarter back, 1 dime back, and 1 nickel, 0 pennies. So 1, 1, 1, 0. Or let's just do 41 cents. So we get 1 of each, just to make it easier on the eyes. So we'll type in 41. And there we go. So we're getting 1 quarter back, 1 dime, 1 nickel, 1 penny. Perfect. Go ahead and move on. For deeper learning on C++, visit us at makethingswithcpp.com and be sure to like and subscribe.